this is going to actually do its thing. I think we are live.
Yeah, my thing popped up. It says we're live.
Oh, cool.
It's cool. It actually shows me that.
All right, I'm just gonna go to the settings here. It's funny because it goes live and then it doesn't. You don't actually know what the link is for the
Until
YouTube.
you start.
Yeah, until you start. Exactly.
That's funny.
Yeah, I think it's. So this is interesting. So now let me go in here. Save. And then we can share this. Then we will just start putting this out on the interwebs. Then, of course, the Discord. So here we are. I'm just setting up my live chat here and we will be ready to go. Dog Toast letting her presence be known. If you can hear her in the background.
What's her name?
Toast.
Toast.
Yeah.
Nice.
Yeah. So if I enter this, I'm seeing if there's a way to actually put the, oh no, that's not what I want. No. So what's happened here? Okay. So great. We have 5 viewers. Let's get a couple more in here.
Oh wow.
Yeah.
Already.
Yeah. Welcome.
That was fast.
I know. Yeah, it's pretty cool.
It is. I've been very amazed by your Discord. It's really incredible.
What I think is incredible is the incredible developers that are in there. I mean, people like Daniel, Gal,
Zanakios.
Zanakios. He's amazing. Alanda.
And even people from the JUCE team that you just kind of see pop up every once in a while, you know?
Yeah, they're all actually in there. They're mostly lurking, but Ruben pipes up every now and then. Yeah, so
I think I've even seen Jules every once in a while.
Oh yeah, Jules is in there. Yeah, because Jules is working on Soul now, and Jules and Cesare, who's the other person who works on Soul with Jules. Yeah, there are some real legends in there. I mean, it's a privilege. Yeah.
It is for sure.
Yeah. There are people from pretty much every major music tech company. There are actually people in there from Google,
Wow.
Google,
Really?
Facebook. Yeah. Yeah.
Wow.
Yeah. Um, yeah. So it's been pretty awesome to see people in there, just talking about stuff.
Yeah.
So, um, cool. We'll wait for a couple more minutes.
Okay.
Uh, yeah. But yeah, I guess yeah, it's been pretty cool. Who else is in there? So we got Google, some people from Google, Facebook, what else? Then like Native Instruments, Ableton, Universal Audio. Yeah, so I've been very lucky. Yeah. Did you see the announcement yesterday that we made about elementary, about
I don't know if I did.
Nick's new API? So he's coming out with this API, JavaScript API that is he
Oh, nice.
yeah, he says it's going to
Like
writing
JavaScript integrated with JUCE.
just pure JavaScript, no JS. Yeah. So it's real time audio.
Oh,
Yeah. So
gotcha.
yeah, it's pretty interesting.
Wow.
There's been quite a pretty phenomenal reaction to it. So
Yeah, that is interesting.
yeah.
I know a lot of people kind of balk at like learning C++, like why can't we use JavaScript?
I know. Yeah. Imagine how much it would open things if you could actually use JavaScript. I think people would be very
Absolutely.
yeah.
And of course, once Soul catches on, I think that it actually has a very similar learning curve to JavaScript in terms of just like it's higher level, it's has a much smaller scope than C++ does. So hopefully if that does catch on and become kind of an industry standard, I think that would also help make things a bit more accessible to newcomers.
Mm-hmm. Yeah, I agree with you. It's interesting you say that because I actually I was given a talk at Columbia University. Well, not actually there, but virtually for Columbia University in New York.
Yeah.
And there
Right.
afterwards, a couple of the students were showing me their group projects that they've written in JUCE, and one of them was actually written originally in Soul. The DSP was prototyped in Soul, and it was really good. Actually, it was like this Formant filter. It was pretty comprehensive.
Oh, nice.
I was very impressed. It could have been. It was very close to be. Aside from the UI, it was very close to being a commercially ready product, something that people would actually use.
That's cool.
Yeah, I was very impressed. I was very impressed by it. Cool. So we have some people here. So I guess we can get started.
Okay.
Yeah. So welcome everybody who is here, and I'm here with Ben Vining, and you're tuning in from New Mexico, right?
Arizona.
Arizona. See, that's what happens when I spend too much time out of the U.S. Arizona and Mexico all kind of together. Yeah. So you're tuning in from Arizona, and we're going to talk today just a little bit about your development journey and about this new project that you've been working on that has got a positive reception, and just a little bit about your development journey, what you're up to, and your future plans. So,
sure.
So I'll let you take it away. So Ben, tell us a little bit about yourself.
Of course. Well, hello everyone. My name is Ben, and I am, or I guess am a musician. I went to college for music composition, and it's kind of surreal actually, like being here and kind of like being now like in the midst of this development journey. Cause I remember like when I was like, 7, 8, my dad bought me one of those like how to code for dummies books. And I tried because I like wanted to be this like, computer kid, whatever, but I did not get it. I did not understand it at all. And in college, I started kind of getting a little bit more into electronic music and music production. And eventually that led me to Max MSP. If anybody doesn't know what that is, it's very much like an object-oriented programming language, except that it's visual. So each class, instance is like a little box that you connect to other things. And it made it really easy for me to understand. And I kind of lived in like the Max world for a little while, building things that I was interested in and kind of getting a little bit more comfortable with it. And then the pandemic happened, and I found myself with time to learn a new skill, which is a very great privilege that I have. But I did, decide to kind of really dig in and learn like how to open up the hood of Max basically and kind of get to a lower level to really kind of achieve the things that I just wanted to do for myself. And it's funny because like kind of the first place that I found trying to learn about what JUCE was and what audio programming was your YouTube channel. So about like a year ago, I was watching your, videos, and for me, I think that my development journey has kind of been like just a series of like, I guess like side quests or like, kind of tangents, because I kind of just dove in head first, telling myself, all right, I'm just going to write a JUCE, plugin that I want it to be, a vocal harmonizer instrument. That's what I've been doing this whole time. I just want to build that for myself so I can use it. And I kind of just dove head in and said, all right, I'm going to figure out how to do that. And after watching like 3 or 4 of your videos, I was like, I need to know C++ if I'm going to do this. And so I kind of went away and I spent like a week like watching tutorials on YouTube. And then I came back to your videos and I said, okay, I'm going to do this more. And then I said, I need to learn CMake if I'm going to do this. And so I went away and I kind of learned how to do that. And I came back and then I said, oh, I need to learn DSP if I'm going to do this. And eventually I kind of found myself at the point where I was just kind of starting to build more things than just the initial project that I was like laser focused on and got me into it. And I was starting to kind of really consider things at a higher level than I think just like a hobbyist. And I really was starting to transform into like, considering this as my career path. So it's been a pretty long journey with like lots of sidetracks and lots of distractions and lots of like things that I learned I needed to know and learned that I needed to build for myself along the way. Because JUCE is great. It has so many tools for you to use and it's so convenient, but it doesn't have everything. You still need to implement your own audio FIFO, MIDI FIFO, and like the JUCE synth classes, which is what we're talking about today. But that was another one of the things that I just kind of said, I need my own kind of implementation of this to really make it super useful for my toolbox. So yeah, sorry, that was a little bit of a ramble, but hopefully that gives you a bit of a picture of kind of like what my background is and kind of like where I'm coming from.
Yeah, well, I think that's really impressive. And one thing that's really impressed me is that you've only been doing this for about a year, and already you're just watching you in the Discord, watching the conversations that you have, the types of questions that you answer. I'm really impressed with how far you've come in 1 year.
Thank you.
It's pretty phenomenal. I don't know if I've ever seen anybody come so far in a year's time, and I thought that was really interesting because on the channel we have so many people who are really experienced. I've been doing this for 10, 15 years, and I think it's important for people to see other people as well who haven't been doing this for such a long time, people like myself maybe, but other people as well who are just getting started, that are just really finding their feet. And like I said, I think that it seems you've made this real commitment to learning C++ and learning audio programming, where some of the discussions and, like I said, some of the questions that you've been answering in the Discord are pretty comprehensive. Stuff that I don't even know about. So yeah, you're talking
Well,
about
thank
different
you.
compilers, talking about CMake, talking about FIFOs. Yeah, so it's pretty awesome. So congratulations.
Thank you. Yeah, like at the beginning, when I was kind of like dipping my toes in and like wading into the water at first, it was, well, obviously it was very overwhelming, but also at first I did kind of have this sense of like, I only want to learn the things I have to, because I just want to do my project. But I did, like, the more I learned about it, the more I kind of realized I actually am really interested in this. And I really do want to know like all the details because it's interesting to me. And so that's why I really kind of have just like dove in and really kind of like studied all the different areas that are interesting to me.
Yeah, that's awesome. And maybe for
Thank
people
you.
who are just starting out, can you tell a little bit about your method for learning new things? How did you, so I guess let's go back a step. Did you do any sort of coding or anything before a year ago? Have you ever written in another language like JavaScript or, well, you said you did Max MSP for a little.
Well, yeah, I did Max for a while, which I don't know if it counts. It's like a visual programming language. And then I played around with processing, which I believe is JavaScript. It's either Java or JavaScript. But I did a
It's
little
Java.
bit of processing for like a couple months, but I never really like finished a product or project in processing. I just kind of like got the lay of the land a bit, kind of started to like get a feel for it. And processing, like it was nice because it just kind of like made me a little bit less scared of actually writing lines of code. It was like, oh, I actually do, I can understand how this works. I can understand how to do something in code, but I never really got to like a super large scale with that. It wasn't until I started with JUCE that I started actually kind of making larger scale products.
That's awesome. So how do you go about learning new things? So when you encounter a new thing that you're trying to learn about, how do you attack that?
Well, so if it's like a really, really large topic, like, you want to learn CMake, nothing about it. You just need to want to learn CMake. My personal strategy, like I started by trying to follow like the JUCE documentation, which I needed a little bit more handholding than that to figure out what CMake was and how it worked. And so I kind of resorted to YouTube. That's generally like my first strategy, actually, because I found your channel, which is very, very comprehensive in terms of DSP. And when I was interested in just like more generalized C++, I actually found lots of very helpful free tutorial series and things on YouTube. So when I was trying to learn CMake, I took the same approach, and CMake specifically is not as well documented on YouTube. So I kind of like was able to kind of get the basics from there. And then I just kind of had to fill in the rest of what I didn't know with a combination of like the JUCE forum and your Discord and my own trial and error. I mean, with any like, project, if the documentation fails you and if tutorials fail you, those are like the three last go-to sources that I can really rely on. And I generally have found people to be very helpful on the forum and on Discord. It's pretty rare that I post a question and either nobody knows or nobody answers. I usually at least get some sort of interaction. And even if somebody doesn't like tell me like the exact answer to my question, I usually like somebody usually says something that kind of leads me there. Oh, and that's another thing I would say too is when you're first learning, obviously you can ask like kind of more generalized questions, but one piece of advice that I would have for people is when you're asking about like an implementation thing or something specific to your code and what you're doing or how you're thinking about it, I would try to ask questions that are as specific as possible on the forum and on the Discord, because sometimes I just kind of see people like post code and just say, why doesn't it work? Or like, tell me how to do this thing. And I think that a lot of people on those places are much more likely to respond to you. If your question is more like, well, I'm getting an error on this line, and this is the error the compiler is telling me. So what's wrong with my syntax in this line? That's a really, really specific question that's easy to answer. So I think that you're more likely to get answers to your problems that way.
Yeah, you make a great point, which is that, and I think we were talking about this the other day in the Discord about how maybe it's just in coding in general that we don't do enough emphasis on how to ask questions and how to ask effective coding questions. That's a technique in itself that can be.
It really is like.
Yeah,
it really is. I think that becoming a programmer, it's like two learning curves, because it's like you have to learn how to write code, but you also have to learn how to be a programmer. And there was a really interesting talk I saw that JUCE did at one of the ADCs a few years ago, where he was talking about like different cognitive biases and how it affects like the code that we write and the way we write code. And I just think that that's so interesting, because we often think of computing and code as like lacking a human element, but that's only true in the execution of the code inside the computer, because as it's being written and developed, it's being written by humans with emotions and with cognitive biases and things like that. So I think that's interesting to think about.
Yeah, I think it's definitely something that is interesting and something I would like to explore more in the future about just the people behind the computers or in front of the computers, maybe. And like you said, the thought process, I think, is so important. There's definitely an effective thought process to writing code. There are definitely biases, and you can tell a lot about a person from the way that they write their code, about the way they organize it, about the variable names that they choose. I think you can That's really true. Tell a lot. It's almost like palm reading in certain
ways. That's true. You can tell a lot about someone.
Yeah. So so let's see. There are a couple questions here on the Discord while we have a minute here. So somebody asking if there is an audio programmer Discord. Yes, there is, and you can find it on the audioprogrammer.com/community. And Brady asks, what channel is, saw the YouTube notification before the Discord one. What channel is this announced in, so I can learn more about what you're going to be talking about? Well, this was kind of actually spur of the moment, actually. So, but we do have something specific that we're going to be talking about. We will get into that in just a moment. And we have a question from Anthony White. I'm studying computer engineering and have a relatively good grasp on C/C++. What would be a good first project to get into the realm of audio programming? What do you think, Ben? What would be a good first project?
The first one I did with JUCE was your gain processor tutorial. And that was really, I think, a good one to do because it was really simple to implement, and it was pretty easy to understand. Like, there's audio coming in, you're multiplying everything by a value, it goes back out. So I could easily understand and see it, and it was easy to put together. And I could put it in, load it up in Ableton and see the audio go through. And that was really amazing for me to be like, oh my God, like it's an actual plugin. And that was the moment I was like, oh, like it's software. Like I'm actually developing software. Like that was a really cool moment for me. So yeah, I would say like some sort of like simple plugin or simple like gain or something, just like really simple that you can actually like load up and like just see that it works. I think that'll be really cool.
Yeah, I really love the gain slider plugin because it teaches you about so many concepts that are important to making a plugin. The difference between what you're seeing versus the data that's being processed in the processor, about having a callback that is coming from one side and relaying data to the other. You have to have a way that you're linking the data together. And of course, a little bit of DSP, just a sprinkle of it. You have the audio callback. And so it's funny that tutorial, I remember when I first did it, it felt really complicated to me. It felt like, wow, this is all this stuff that we have to do just to get a slider on the screen that actually manipulates the value. And but it really does give you an idea of the very fundamentals, the first fundamentals to actually building an effective plugin. So yeah, that's
it does.
Gain slider is a really good one. Then from there it just goes up from there. I mean, I think a lot of the tutorials that I've done on the channel have really been my own learning experiences. Stuff like playing a file, loading and playing a file is another good one. Once again, not the easiest thing if you're just learning everything. There's a lot that you need to know to get it started. But that's what the Discord is there for, really. It's for getting through these rough spots. I was working today, doing some coding today, and I was just thinking, wow, about how lost I was before I knew any sort of C++, and I was just fumbling around, because as you get it, then you start going on automatic pilot, and you're like, okay, this is the location of this. This needs to be a pointer. This needs to be dereferenced. This needs to be So it starts.
Yeah, when I first started watching your videos, I was kind of under the impression that JUCE was like its own like thing, kind of like Max, how it's like it's a little playground like set up for you, and then you just kind of play in the playground. I thought that that's what JUCE was, and there was another kind of realization moment for me when I really kind of understood, oh, JUCE is just C++ code. And it's just all C++ to the compiler. It's not anything special. It's just more C++ code. That's when I really kind of understood, oh, I do need to know C++ and how it all kind of fits together.
Yeah, that basic C++ knowledge is, I admit that when I was first learning JUCE, I used to maybe circumvent that in a lot of ways.
Yeah.
But if you have at least a base knowledge of C++, you will understand so much more. I mean, we have a series where I actually teach my son how to do C++, and
yeah,
I think pretty much. I think we're nearly at a point. Well, we actually had a evening the other day together where he was walking through JUCE kind of ahead of me, and we were just starting to break down a lot of the concepts. Just talking about the audio, just talking about a JUCE project and how it's put together and where it's inheriting, where the processor is inheriting from a JUCE audio processor. Okay, so what does that actually mean? So I think we're nearly at a point now where through the lessons that I've actually given Alex, that he can pretty much jump into it. And there's still some other stuff. There's still some other stuff like casting and a few other little things that he will learn along the way. But I like that confidence to be able to tell somebody, if they're just saying, oh, I'm just starting out, just to say, watch all these videos and you'll have at least a good foundation for what you need to do, what you need to know about before jumping into JUCE.
That is super cool.
Yeah. So we have another question. For someone with no experience with any type of coding, would you still recommend trying to follow the gain slider tutorial?
Not before you learn a little bit more about C++.
Yeah, just a little bit of C++ is very helpful. It's very helpful, because otherwise what happens is, because if the syntax isn't exactly right, you get stuck and you don't really understand why you're stuck. And like I said,
go ahead. Like I said before, like that's kind of how I started, was just jumping into the audio programming tutorials. And I will say, if you're gonna do it that way, I would encourage you, if you find yourself like, typing something into your code and you don't know what it means, you're just typing it because Josh typed it in the video, I would encourage you to like pause the tutorial and go and research that and like learn what you just typed and what it means, and then continue the tutorial. Because at first I found myself doing a lot of that and kind of like just putting it in there and like, oh, okay, like it just says that because it says that. And those were all things that I eventually found myself having to go back and like learn anyway. So I would just encourage you, like, and that might be everything at first, but just, I would encourage you just keep doing that until you have to like pause the video less and less and less. And then eventually you can just do a tutorial and you understand the C++ at play.
Absolutely. Absolutely. That's great advice. Cool. So, but we're here to actually discuss something specifically, aren't we?
Yes.
So you've been working on something. Tell us about what you've been working on.
Well, so the personal project that I've been working on is a plugin that works a lot like a synthesizer. And so at first I used the synthesizer classes that JUCE has built in, and I kind of had to like pull them apart a bit to get them to do all the things I wanted it to do and add a lot of stuff into it. And then eventually I said, okay, I'm just going to take out my inheritance from the JUCE and just handle it myself. But it was still kind of all in my code for like this project that I'm working on. And so I had this like huge processor class, for my plugin, and but it worked and it was fine. And then one day I said, I want to do another project that has a lot of these features. And I was looking at it and I go, oh God, I got to copy all these lines of code just to get this thing that I implemented. And so I decided to kind of abstract it out and create my own synthesizer base classes. And for several reasons. First, I was really interested in learning how the JUCE ones work and why they're designed the way they are, because I just had an interest in like understanding at a lower level how that is like put together, but also because there were a lot of things that I just kind of considered pretty basic functionality that the JUCE synth classes don't provide. Like, for example, one of the most basic things is like an ADSR in each of your voices. Well, the JUCE synth class doesn't provide that for you, but I found myself wanting pretty much on every single project, I found myself like putting in a JUCE ADSR and pretty much the same management logic for, is the voice still on? Is the ADSR off? And, it's not the most complex logic, but putting it in every single project, I just was thinking to myself, there's a better way to do this. And so I ended up creating some base classes that allow you to just focus on the actual audio generation that is specific to your synthesizer. And the base classes take care of everything else, all the logic of keeping track of, is your voice currently on, all the ADSRs, preventing pops, even taking care of things like the stereo spread of your voices and assigning panning values to each of them, and everything like that. So we are here today to kind of go through my base classes and show you how to use them and show you how they're put together and like kind of the basic structure, because I wanted to make them available for everyone to use.
Fantastic. Yeah. Would you like to share your screen and give us a walkthrough?
Sure. Let me see here.
While you're doing that, I'm just going to answer a question from Cheese Soup. Cheese Soup says, I learned C++ recently and I'm currently working myself through the tutorials on the JUCE page. It is so much. Should I learn stuff by hand or memorize what is going on with the tutorials? I just get my hands dirty quickly, and in the end, will it all come together, or should I be afraid? I think it just takes time. It really does, and I think a lot of it is just about just hanging in there. Really, just trying to do something simple, one thing at a time, and it really is crawling. It really is just. It's like learning any other skill, riding a bike, playing an instrument. It's just like that. You won't be good at first, and everything's all over the place. But you just have to really hang in there with it. Ask a lot of questions, and just just really just keep going at it. Cool. So you've got to sign off and sign back in. Is that right, Ben?
Yeah, my computer's being annoying.
Oh yeah, it's the Mac permissions thing. I know all about it.
Yeah, it is.
Yeah, that's
so
cool.
I will be right back.
Okay, sounds good. Great. Yeah. So while Ben is getting his computer straightened out, I'll touch on that a little bit more. So like I was saying, it's all about really just hanging in there, doing one tutorial at a time. The tutorial series that I did for the original tutorial here on the YouTube page is really like my journey, the stuff that I learned. So you'll hear a lot about my thought process as I was learning new stuff. Just follow along with those, and I think you will find that you will become more familiar with it over time. So yeah. So Ben's back, and I will answer one more question while Ben is getting ready to share a screen. So the Samex 80 asks, how can we with JUCE create a professional GUI? That's a user interface. I mean, use custom PNG files or images and apply it to it. Yeah. So this is something that we're going to actually talk about soon on the channel, which is how to implement your own UI. So there are two ways that people typically create their custom UIs. One way is procedurally. So which by that, what I mean is that you use custom fonts and you actually create your graphics in code. So something like Serum would be an example of a UI that's been created procedurally. So that's all been created in code, not using PNGs, and that you and so for that you use the JUCE look and feel classes, and that provides a lot of functionality for creating your own UI. You have to kind of know what you're doing though in order to do it. But JUCE actually provides quite a few tools for doing it. It does like gradients. You can interpolate colors. You have stuff like alphas where you can do things like transparency. So JUCE is actually pretty comprehensive for creating UIs. I think it actually ranks up there with one of the top C++ frameworks for UIs.
So
yeah, full stop. Like even outside of audio. So yeah, but then there's
the other way.
Yeah. Go ahead, Ben. Do you know about that? Have you done that before?
I've not done it.
Yeah.
But the person that I'm working with on like designing my personal project loves like React. So we've talked about it a lot. I think we're going to stick with JUCE because that's what I know, but yeah, I'm aware of it.
Yeah. So the other way is using PNGs and SVGs. So that means that you would have a graphic designer or you yourself would create graphic assets, and then what you have to do is you have to bring those in as assets, graphic assets into your project, and then you have to essentially draw them on your components, your visual components. In order to actually be able to use them. I touched on that a little bit. There's a tutorial in my JUCE sampler series that where you can actually where it talks about how to actually bring in like your own image and things like that. But it's something that I should definitely cover more actually. And somebody
it's such a complex topic.
It is a very complex topic, especially when you start talking about multiple windows. You start talking about there's so much that you can do
and
with
skinning a plugin.
Yeah, skinning a plugin. Also the timing, like when like smooth timing between windows where you click on a button and something smoothly animates from
yeah,
another.
That's tough.
That's tough. Yeah, it's tough.
Yeah, I think the GUI code oftentimes ends up being more complex to get written than the actual DSP code.
Yeah, yeah, I would agree with that. Yeah, there's definitely a lot that goes into the UIs, and you can see it with some of the amazing UIs that companies are doing now. Somebody asked, can you manually resize the PNGs in real time? Yes, you can. Yeah, yeah, you are able to do that, but you have to know how to do it.
Yeah. To
Yeah.
do any kind of resizing on a ping or like any kind of image file, you can. But the more recommended way would probably be to vectorize it so that you have like a path instead of an actual like bitmap, because then it's just like basically a series of math equations rather than like an actual set of like data representing pixels. Because especially if you're trying to enlarge, then you can get things looking kind of blurry. But yeah, if you have like a path or like an SVG, then you can like resize it any way you want and do also kind of like additional manipulations, and JUCE has tools for that as well.
That's right. That's right. Awesome. So now let's move on into your project. So this looks impressive. So you got some asset
Yeah, can you
art up
see
there.
this?
Yeah. Yeah, we can see it.
Yeah,
So yeah, go for it.
cool. Well, so anybody who hasn't seen this before, if you go through the JUCE source code, all of JUCE is organized as a series of what they call JUCE modules. And so every like JUCE module that you look at is going to have this block at the top, and this just kind of tells you the module name, who made it, version, and then any dependencies. And this is my other project that I have been working on, but basically it's just kind of like a set of generalized utilities that I use in all my projects, and this also depends on that. So they're both permissively licensed though. So if you want to use this, you can just include both, and they're both free to use. So these classes are laid out in a very similar way to the JUCE synthesizer classes. So this is the top level, like synth. This is basically the equivalent of JUCE synthesizer. And basically, you're seeing a lot of similar methods to like what JUCE has. This is the top level rendering call. It's called render voices. It should probably be like render block or something. I just haven't changed it because I already have used it in code in some places. So that's what that is. But yeah, there's a whole lot of methods here, but they should be fairly self-explanatory. But basically, this is just kind of like an instrument that owns and manages a series of these objects. This is the synth voice base class, which is kind of the equivalent to the JUCE synthesizer voice class. And so each one of these objects holds like the state of a single synthesizer voice and plays a single note at a time. And the major difference between my classes and the JUCE synth classes is what happens inside here. So this is the CPP file for the synth voice class. And render block here, this is actually not a virtual method. And this is what gets called from the parent during all of its rendering calls. And this is what implements kind of the logic that I was talking about. So this is what takes care of like MIDI velocity gain, aftertouch, ADSRs, like quick fades to reduce pops and panning and all of that stuff. And so that logic all happens in here. And this method actually calls, where is it? Right here. This is the virtual method that user classes should override to implement their functionality. So this method is called render please, which is like a little bit tongue in cheek, but it's just because like it's asking you to make some new audio. So from the perspective of the actual base class, synth voice base, what's happening is it's just going to your kind of overridden like class that you've inherited. And it's just saying, all right, get me some audio at this frequency. And then it just does everything else that it needs to it. It takes your audio that you gave it and it applies MIDI velocity gain, aftertouch, ADSR, panning, and everything else. So in your class that you're inheriting from, all you have to do is override this method and generate, the audio that it wants. And every time it calls this method, it gives you the current output frequency in hertz, and it also provides you the current sample rate just as a convenience. So it makes it very, very easy to keep track of like all the different things that can affect, like a voice's note, like for example, pitch bend, the pitch bend like range setting of the parent. And like there are lots of various things that can kind of affect that. And so this just takes care of all of it and just tells you, here's what frequency we're at right now, make me some audio. And another interesting thing that actually came as a request from somebody else, there is an open source library called MTS-ESP. And I didn't know about this until I like posted this on the forum and somebody said, hey, can you include this? And what it is it's a library for microtuning management. The way it works is you can have what they call like a master plugin somewhere in your DAW project. And in that plugin, you can set like a tuning table. You can map every single note of a keyboard to a different frequency. And you can even do it for like each specific MIDI channel. And then it will communicate that tuning information to every single plugin in your DAW process, like in the chain. So that's super cool. And I did make it optional. So you don't have to use it if you don't want to, but if you do want to use it, it is here. And basically the way it works is that it just kind of queries the master, if it has one right here. So if you're not using it, then when the voices ask, hey, what frequency should I be at? Then it just returns it to you based on the current like concert pitch setting, like how it's converting MIDI to frequency, and then also the current pitch bend, like if it's got, a pitch bend active. Otherwise, it takes into account pitch bend, and then it also asks MTS ESP, hey, what frequency is this note mapped to? So it should work either way, like whether you want to include that or not. I just added that as like an extra cool, like little feature. And there's some other kind of like extended functionality that I wanted to bring up as well. I've added what I'm calling pedal pitch and descant voices. And what these do is if you turn it on, so it's optional, you don't have to have it on, and you can turn it on and off dynamically at runtime. But what these do is pedal pitch scans all the currently, active notes, and it finds the lowest note currently held by a keyboard key, and it creates a harmony voice that is doubled at a specified interval below that note. So basically you can tell it like the interval that you want it to create. And then you can also say if the lowest keyboard key is higher than a certain note, then don't create the doubled voice. So you have a threshold and an interval and an on-off, and descant does the exact same thing, except it's above. It finds the highest keyboard key and doubles it at a certain pitch above if the highest keyboard key is above a certain note. So hopefully that makes sense. But oh, and there's one more thing too. MIDI latch. This is something that I am still experimenting with. Currently, the way this works is if you turn this on so that MIDI latch is on, then if anytime you press a key, note-ons go through like normal, but any note-off events that are received, it doesn't send through. It just kind of holds them in a list. And then the next time you turn MIDI latch off, then it turns off all the notes that haven't been like, you don't have, pressed down anymore. And I'm still experimenting with this because what I would ideally like to do someday is have like a feature that kind of, instead of like replacing all the notes and having to manually turn it on and off, it would be more like, press a chord, press another chord, and you're able to like release. Haven't figured that out yet though. What else is there in here? Oh, okay. So the pedal behavior, I've tried to emulate a typical piano. So the soft pedal, basically you can set like a multiplier, basically a gain multiplier. And then it says like, if the soft pedal is depressed, it just applies that gain to all the voices. And then the sustain and sostenuto pedals attempt to replicate the behavior of the way that an actual acoustic concert piano works. So let me get this right. The sustain pedal sustains any notes. So like if you hold the sustain pedal down and then you like play some keys and then release them, those notes would still be ringing. The sostenuto pedal only sustains notes that were held down at the moment the pedal was pressed. So if you're playing some notes and then you press the pedal and then you release those notes would be ringing, and you play some other stuff, those won't ring. So, but the point is, the idea is that it's basically attempting to emulate the way that like a typical piano would work. And of course, you don't have to use these, you know, features. And the other thing I want to say is that if anybody is looking at this and is like, you know, this looks great, but, you know, whatever your but is, anyone is free to use, you know, copy, paste, and edit. Anyone is free to kind of use this as like a basis for their own project and, you know, edit functionality or take things out that you don't want or add more to it. Maybe we can post a link to the GitHub repo that this is on somewhere, but pull requests and forks are always welcome. The point of this is that anybody can use it. And I added, yeah, I'm trying to think of just like anything else. So there's also a play chord, you know, you can just have it automatically like trigger a certain chord of notes. Oh, this is something else I added here. So one of the things that I did not like too much about the JUCE synthesizer classes is that they often expose the actual voices to the outside. And so I often see people like in their, you know, plugin processor kind of doing things that like iterate over the voices or having to like add and remove voices like actually from the plugin processor. And that's fine. You can do it that way, but I decided to make a change num voices function. And the way that this works is if it needs to remove voices, then it tries to search for ones that are inactive first and delete those first. And then if it needs to add voices, it calls a virtual function that you can override. So the default implementation will return just some instances of this base class, the synth voice base. But if you're implementing your own synthesizer, this is like a little example here. This is what you can do. You can just override add num voices and make it add a new instance of your overridden implementation of this base class. And then what that allows you to do is, because you've overridden add num voices, then you could take, you know, an instance of example synth here. And from the outside, you can just say example synth, change num voices. And then internally, it will take care of either adding or removing. And if it does add any more, it will be instances of this class that you've implemented here. So that's, I'm trying to think if there's anything else that I haven't mentioned that is different from the JUCE synthesizer classes. We have MIDI velocity sensitivity. So if this is, it's an integer between 0 and 100, because I'm basically thinking of it like it's a percent. And so the way this works is that if this is at 100, then all velocities get through as normal. And if this is at 0, then everything is just given like a gain of 1 for the velocity. So it assumes that it's the maximum, basically. And then pitch bend, you can set individually the range in semitones up and down for pitch bend. And if you want to in this function, you can also send negative numbers in here. And it should still work. I don't know if I've tested that, but you should be able to say, like, if you're pitch bending up, you can set the range as like, you know, negative semitones, and that would reverse your dial if you want to. Concert pitch, this is for if you're not using that microtuning library that I mentioned before. If you are using that microtuning library, this function will do nothing. And this is one of those like C++ object-oriented programming questions that I've kind of been thinking about, is like how to handle this, because there are also like there are just, I don't want to have a function here that like needs to be there all the time, but does nothing if you're, it's a little bit strange. And I'm thinking about how to handle this better. So if anybody has suggestions on the implementation of this, I'm open to ideas. Stereo width. Sorry, I'm just kind of like going through this file. I don't know if I'm like rambling.
Oh, please continue. I think a lot of people are interested in this.
Okay, so excuse me. Stereo width. This is an integer between 0 and 100. And basically, when this is 0, every single synthesizer voice will be in the middle, and it'll basically produce a mono signal as output. And then when this is 100, the like kind of available panning values will be spread over the entire stereo field. But I should also mention that the way that I wrote the rendering methods is that if the audio buffer passed to the top level rendering call of the synthesizer only has one channel, then it will give you mono output. Even if you've configured it to be like a wider stereo width, it will just give you mono output in that case. But if you have said here, like, 100 stereo width, and then you send a 2-channel buffer to the rendering call, then it will give you voices that are nicely spaced in between the stereo field. And the way that I implemented this for stereo width was I really wanted it to essentially kind of be like from the middle out. So basically, the way it works is that every time you tell it what the new stereo width is, it creates like a list of like allowed panning positions within the stereo field, basically. And then it like reorders them from the middle out, right? So that it kind of gives you this one first, and then this one, and then this one, and then this one, and then this one. So that as more voices turn on, the signal kind of spreads out. So that's the stereo width. And then you also can set a lowest panned note. And the idea here is that like, if you want all your really low bass notes to just always be right in the center, you can do that as well. And then this, so anybody wondering about this quick release milliseconds here, I mentioned quickly before that this also takes care of preventing pops. And of course, the way you do that is by having a like quick fade out if you're trying to like stop a voice, quote unquote, immediately. And this just controls how long that quick fade out is. The default is, I think, something like 10 milliseconds, but if you want to control it more specifically, you can. Yeah, and then over in the actual voice class, this is very similar to the JUCE synth voice class. And the way that I've written this kind of little framework here is that generally, like, I've pretty much only exposed const methods of the voice as public, because I in my personal projects, I almost always from the outside just interact with the actual top level synth object and just let it control its voices. And if there's more functionality that anyone needs to be able to like kind of access these voices like from the outside, let me know, and I'd be happy to consider kind of editing the way this is laid out. But as you can see, this is a much smaller class. So like I mentioned, the render block here is what gets called from the top level class. Maybe I should actually show you some of the method implementations here, but this is the top level rendering call. And if you actually look into the JUCE source code for the synthesizer, this looks very, very similar. The way I started writing these classes was just literally copying from the JUCE source code. So sorry, Jules, if you're watching, but yeah, so I kind of edited this to make it a little bit more like what I needed and for my purposes. But it's very, very similar. And so, yeah, what it calls here is anytime. So just to kind of explain, and this is also the way that the JUCE synth classes work, but the way that it works is every time you call this function, you have like an output buffer, you want a certain number of samples, and then you have a set of MIDI messages. And the way it works is that it scans your MIDI buffer and only processes audio in chunks in between the MIDI messages so that the reactions to the MIDI messages remain synchronous with the audio output. And so each time it wants to render a little chunk in between MIDI messages, it calls voice render block here. And this is the one that is not a virtual method and contains all the kind of like base logic. And that is what in turn calls render please, which is, this is the virtual method in the other class that needs to be overridden. So are there any like implementation questions or like functions that you want me to kind of like go over more specifically and talk about like how they work and how they're written?
No, this seems pretty clear to me. So at first I thought that this might have been a wrapper around JUCE's synthesizer classes, but this is actually your own implementation and then kind of extension of their classes,
Yes.
but largely based on their implementation.
That's correct. Yeah, it started as a wrapper around the JUCE synth classes, but it quickly, and I mean, kind of thus is the nature of object-oriented programming, but it quickly got to the point where I was just overriding so much stuff and re-implementing like so much stuff that I just needed to be different, or adding so much like additional stuff that it just eventually I thought made more sense to just have my own set of classes to inherit it from. And the other thing that gets you is that you don't have any kind of like inheritance chains going on, because if you had like your own synthesizer object that was inheriting from mine and mine was inheriting from the JUCE one, then you get kind of this kind of like chain, and sometimes that can have unintended effects. So yes, these are their own standalone classes that have no inheritances.
Nice. And I bet you must have learned a lot from
I did
digging into how JUCE did it and then just going through that piece by piece.
I really did. It was very, very instructive. And, you know, like at the beginning, when I was first starting this, I was kind of, you know, like I asked a question or two here on, you know, Discord or the forum, and a couple of times I got the response like, well, why are you reinventing the wheel? Why are you rewriting this? Just use the JUCE ones. And at first it was maybe a little bit stubbornness, maybe just a little bit like, you know, no, I want to learn it for myself. But I am like really glad that I did it, because it taught me so much about the way that synthesizers work, and also like just design for object-oriented programming. One of the biggest things that like kind of informed how I think about object-oriented programming, the kind of first iteration of this, like when I first started my own plugin project that I'm working on, and like before I was even using the JUCE synth classes, like I was just kind of freely like, you know, doing all my own stuff. Like the first thing I tried doing for controlling note events and stuff was making like an array of active notes. Mm-hmm. And trying to keep track of like which voice object was playing each note in the array, and then in the array trying to figure out like, and when I looked at the JUCE synth classes, all they do is they pull their voices, and each voice, they just say what note is that voice playing. So there's no like array of data anywhere that has to be kept in sync. All you need is the actual voice objects to keep track of their own state. And that was very informative to me. So like if you take a look through any of like my kind of parent logic methods, a lot of what you will see let me find a good example. But a lot of what you will see is kind of like just asking the voices for their own state. Like here, I could try to have like some kind of array of notes or something like held in the parent and try to like map them to which voices are playing which notes and then turn those off or whatever. Or you can just iterate through every single voice and say, if you're active, then turn off. And that is so much simpler and also less bug prone. And that's like a really obviously very simple example, but the same thing is true in all of these note rendering methods, which look kind of scary at first, but they work pretty much the same way. Yeah, it's like the voices store their own state and you just kind of pull them instead of trying to store the state in two different places and keep it updated. And so I don't know if anybody else like has fallen into that trap, but I just found that personally very informative in terms of like object-oriented like design considerations.
Yeah, that's something that I've definitely been running into quite a bit, is just this question of where objects should hold their state.
Yes.
And I think that I'm finding that a lot of times it should be in the lowest level possible. Is that what you're finding as well?
Yeah, I mean, it's always hard. It's always hard. And there's like always a lot of different questions to keep in mind. So currently, the way that this is organized currently is that inside each individual voice, they all keep track of their own, like, panning. They all have their own gain smoothers for each of the, things, and they keep track of their channel, they keep track of their note. But the parent keeps track of things like the sample rate. The parent serves as like the connection to this like micro tuning library, or if you're not using that and you want to modulate the concert pitch on its own, then like the parent keeps track of that, and the voices just pull the parent for that information. And you could make the argument, well, you could get rid of the overhead of that function call by storing the state in each of the voices individually. But then you have to keep it updated in each of the voices individually. So then you have more data, and then there's the possibility for like inconsistencies. And so there's always a lot of like conflicting concerns, but like, yeah, I agree that I think that like anything at the lowest level that is like specific to that low level object, I would hold in that object. But then anything that like multiple objects need to replicate or need to know about, I would hold in either some parent scope or parent object.
Yeah. Yeah, this is great. This is awesome. So is API writing and this type of coding, is this interesting to you? Is this what you enjoy?
It is. Yeah. I am like finding that I do really enjoy doing this. And like I said, this dependency that it has, my little shared code, that's another kind of like basically extension to JUCE that I've been working on. That's just kind of like, got some classes and utilities in it that I use for my own personal projects. But as I've been working on like fleshing this out and fleshing that out and some other things that I've got in the pipeline, I am really kind of learning that I do enjoy not just audio programming and making end products, but I do enjoy like making the tools that are used to build products as well. And I actually do I do enjoy like, conversations about like, what's the best way to design this class from an architectural standpoint. I think that kind of thing is really interesting because it's like a puzzle. It's like, Tetris. What's the best way to figure it out and fit it together? So I do find it very, very interesting and very compelling.
Have you shown this to Ruben yet?
Not yet.
You should show it to him. Yeah, I think he'd be quite impressed. Yeah.
Thank you. Yeah, maybe I will.
Yeah. I don't know if you know, but they're looking for another developer right now.
Yeah.
Yeah. But yeah, it's I don't know. The thing is that I think that API writing is a whole different skill from product writing. And some people do it really well. Like Teamer Dummler, like he's worked on the,
Yes.
but he's also
He's
worked
amazing.
on products as well. He's fantastic at doing both. I think
Yeah.
Ruben fits into that category as well. He's done both,
Yeah.
but it definitely takes a special type of mentality to write APIs and
It does.
to write frameworks.
It
Especially
definitely does.
especially like you were saying earlier, that you have a method and you named it something, and now you're using it in a couple places, and so you don't really want to change it. But imagine if hundreds or possibly thousands of people are using your code.
Absolutely. Yeah. And even just like something this size, like putting it out into the world and saying, hey, go use it, like that, like, is also kind of nerve-wracking, because it's like, oh my God, like I need to commit to this now.
Yeah.
And like you said, API writing and writing frameworks and things like that for just kind of generalized use is a very different thing, because you don't have to just think about the way it's going to be used in one product. You have to be thinking about the way it could be used in any product. And I will admit that in this implementation, I think that there are a few things that are just kind of holdovers from the fact that this originated in one of my projects that I kind of abstracted out. Like, for example, the pedal pitch and descant things might be something that no one except me ever uses. I don't know, but it's there because I needed it. So there is a little bit of that going on, I'll admit.
Yeah, that's really cool. That's awesome. Yeah, you should definitely show this to Ruben. I think he'd be quite impressed.
I think I will.
Yeah. Have you met him yet? Do you know him?
I've chatted like with him on the Discord. Like we've gone back and forth on like a few questions and things. But like that's pretty much it so far.
Yeah, you should meet the JUCE team. I could introduce you to them. I think they'd
That would
really
be amazing.
I think they really enjoy seeing this.
That would be amazing.
Yeah. Awesome. Cool. Yeah, thanks for this. And I've shared the link. Already in the chat, but I'll also share it in the description after the when I go back and I edit the video. But yeah, I think this is really impressive for somebody who's been developing for about a year. Really cool. A lot of stuff that I haven't even done. I don't use a lot of macros, if ever. I've written one module. Yeah, there's a lot of really cool stuff, and I think that also your const discipline is really good as well. Understanding stuff like const, no accept,
yeah,
things like.
Well, I think it helps that I'm like a little bit OCD. Like this, like it bothers me that like the JUCE team doesn't do this. They always just have their arguments as like int or whatever. And like I know that's kind of a hot topic and like very debatable, but it bothers me. I'm like, no, like I want to know that my function isn't doing something stupid and changing this argument, because it, that's it's const, it's the value that, I don't know. It's a hot topic, but for me, it's like one of those like OCD things that it like bothers me if I don't do it.
Yeah, I do that as well in my when I write my functions, and I thought, like, looking through the JUCE code, that maybe because they weren't marking theirs as const, maybe I was doing something wrong. But I don't know. I did a little bit of research about it, and it seemed that it was perfectly sensible to do it. Yeah.
Yeah. I think it's kind of like a preference thing. I don't know.
Yeah, I don't know. To me, it just signals that you're not intending on changing the value. You're just intending on changing the value, and that
exactly.
And I thought, I can't remember where I read this from, but you're supposed to mark variables as const whenever you can, from my understanding. So
well, that's kind of like the how I. Oh, that should be a const. But like, yeah, that's kind of how I like approach it as well. You know, because I just like to try and eliminate as many possible bugs as possible.
Mm.
And like not writing const everywhere might make the code a little less verbose, but I just think that like even if there's a possibility of it messing up unintentionally because it changed the value or whatever, I would just rather not even open up that door.
Mm. Yeah. Yeah. This is great. So what's in the future then? So you have some products that you're working on? Is that what you're doing?
Yeah, so I have several like kind of projects in the pipeline, but the project that got me into coding in the first place, that I first prototyped in Max and am now working on implementing in JUCE, is a vocal harmonizer instrument. So it's essentially a synthesizer that creates its audio output by pitch shifting and input audio. And it uses these base classes as its infrastructure. And the implementation just basically like in the voice base, it overrides this render please, and it just kind of has a pitch shift algorithm in there. Doesn't work yet, but it will.
Nice. Yeah, I thought I saw a video somewhere that was you singing and were you using like a harmonizer? Is that?
Yeah, and that was Max.
Oh,
So
nice.
I prototyped it in Max, and it worked fairly well. But I didn't write that like Pisola object that I used in Max. I didn't write that myself. I found it somewhere. I got really lucky.
I see. I
Um,
see. Do you have
and
that video on hand? I think people would love to see it if you have it
uh,
handy.
sure. Yeah, just to give you like the basic idea of like what the end goal is. Um, my screen sharing is paused. Why? Why is that?
Hmm.
Can you see my YouTube?
Yep.
Okay. Yeah. Oh, hey, look.
Small world.
I don't know if the sound is going to share. I don't know how that works. Can you hear that?
No, unfortunately not. Oh, that's a shame.
Uh, I don't know if that's like a, oh yeah, here, share sound. Password. Oh God. I can share sound, but I have to install something.
It's so wild.
Anyway,
Yeah.
we can share this link too, but basically the point is like you sing and it changes your voice to all the various like pitches that you select. And so that was actually a big like reason that I started this whole journey of like implementing these synth classes, is because at first I had all of this in my kind of like harmonizer class, and it was like thousands and thousands of lines, and I said, okay, I can't deal with this anymore. Like I just need to get these at least into like different files, like a different module. I just need to separate this logic out. And the funny thing about it is, now that I have all of this abstracted out into its own module, the actual, here, maybe I can show you real quick. But the actual like harmonizer, like pitch shifter implementation is fairly small now, which I actually think is kind of funny, because like and that's like the point of doing this, is that you only have to worry about your actual audio generation. You don't have to worry about MIDI logic or like any of the other things that like are fairly fancy that those base classes do for you. But here, can you see this now?
Yep.
Okay, so here, where am I looking? So this is the top level like harmonizer object inside this project of mine. And as you can see, it inherits from my synth base class. And basically, what am I looking for? Oh, sorry. I'm looking for the voice. Okay. So yeah, the top level object overrides the add num voices like I showed you to return a new object of the actual harmonizer voice type. And then this, because it's a pitch shifter, I just have this function that kind of like analyzes and stores the input audio so that the voices can reference that data in their rendering routines. And then I made a top level render function here. And the synth base class does not have a function called render. Remember, it's called render voices. So that's what this is doing. You call from outside here, you call render, which calls analyze input and then render voices, because I always need it to happen in that order. So that's specific to this. But in the voice class here, as you can see, I override the render please. This is what gets called by the synth voice base class. It calls this in turn. So all this has to do is say shifter get samples, and that's it. So this harmonizer voice and harmonizer class are actually both very, very small now, which I just think is kind of ironic because it's doing something like very sophisticated and fairly, advanced, but they're both like very, very small classes.
Yeah, this is really cool. Very nice. Yeah, how far away are you from getting it from finishing it now?
Well, I'm getting there. I need to do more like figuring out with this like kind of Pisola algorithm.
And have you written this yourself?
Yeah, all of this was written by me. But basically, the way that Pisola works is that you need to take like little grains of the input audio that are about like a period long, centered on the little peaks. And then you basically just kind of respace them to be like a different distance apart to create the impression of a new period. And that's how the pitch shifting is done. So basically I've created two objects, like a Pisola analyzer and a Pisola shifter. And the analyzer basically just kind of like extracts these like grains, from the input audio. And then the shifter, when you ask it for more samples, it it has like a certain number of grains that are active, and then it like on each one of those it adds the next grain, and then when it needs to start a new one, it starts a new one. And I'm like fairly certain that this is working properly, but this is like where my issues are, because I'm having some issues with it like not starting the correct grains and the overlap being like a little bit incorrect. So I need to still kind of work on this, but there have been many steps, because like the whole process itself is dependent on pitch detection. So first I had to write a pitch detector, and then after that you need to extract these grains, which involves like this basically, which is like attempting to detect the like peaks in the audio that are approximately a period apart and like have the right amount of overlap, and trying to like make the ideal kind of grains. And then after that you need to use them, and then resynthesize them. So it's a very multi-step process.
Wow. I mean, to write a granular resynthesis engine in your first year of development, that's pretty phenomenal. I hope you're giving yourself a pat on the back for that. That's
thank you. I mean, it doesn't work yet, but we're getting there slowly but surely.
Yeah, pretty cool. So once you finish this, would you be bringing this product out under your own name? How would that work?
I don't know yet. I'm conflicted. I mean, because I've been working with do you know Evan Berard from the Discord? And
also Evan B, of course. Yeah.
And also Florian Rugala.
Yeah.
So those two, Evan has been working with me for a while now on like kind of designing a basic concept for how this UI is going to look. And he has been really, really great actually, because like he's like taught me a lot of things that I didn't know I needed help with, because like at first when we first started talking and he was like, I want to help you design your GUI, I was like, great, here's a list of 50 parameters that I have for you to put in the GUI. And he was like, that's great, now let's figure out how a user is actually going to use this practically.
Yeah.
And so we've been doing a lot of things like kind of making, you know, like meta parameters that under the hood are translated into controlling more than one thing, but the user doesn't necessarily care about all of those and stuff like that. So he's been really great. And Florian has recently come on board to help with like designing some spleen editors and things for like envelope control. So I need to talk to those two a little bit more. I don't know yet.
That's really cool. That's awesome. Yeah. I really would. That'd be amazing to see the three of you team together and come out with this product.
Mm-hmm.
Yeah.
Yeah, it's gonna happen.
That would be really cool. Well, if there's anything that that we can do to help that out, let me know. But
thank you. I appreciate that.
Cool. Awesome stuff. Well, I think this is a good place for us to wrap up.
Sure.
Is there anything else that you want to mention? Do you have social media? Do you have any like an Instagram or Twitter or anything like that that people?
Oh yeah. Sure. Well, so I am actually an electronic musician as well. I haven't done as much like recently because I'm kind of distracted with coding at the moment. But if anybody is interested, I can send you a link to my SoundCloud. And I have like SoundCloud Bandcamp. And then if anybody is interested, I am on Twitter and Instagram as well. So I can send you links to my my social media.
Yeah, that sounds great. And I will put those in the description. And
wonderful.
Yeah, great. Awesome. Well, thank you very much. Yeah. Yeah. Thanks for sharing this with us. I think a lot of people are going to be very impressed. And
yeah,
like I said, we should show this to the JUCE team. I think they would really like to see it. And
that would be awesome.
Yeah.
Yeah. And just to reiterate for everyone watching, all the code that not the imaging code, but the synth-based code that I showed today is completely free to use. You can use it in commercial products if you want. You can copy it and edit it if you want. It's completely free, permissive. You can do whatever you want with that code.
Amazing. Yeah. And I think it's just really admirable that you've done this open source for other people as well.
Yeah, I mean, I think as programmers, we're kind of all standing on the shoulders of those who came before us, right? Because in one lifetime, you can't invent transistors and high-level programming languages and compilers and assemblers. Like, we're all using tools that have been made available to us. And I've been really, really lucky. I said before about how like I kind of found myself with a lot of time to learn because of the pandemic, but also because of the pandemic, my finances got a little bit tight. And so it was really, really lucky that I was able to find a lot of free resources and free, like, you know, guidance and people who were really willing to help others learn. And so I really kind of want to pay that forward and make all my code available and say, hey, you can use this, you can learn from it, you can copy it, you know, because that's how I learned. And so I want to say, yeah, like pay it forward.
Absolutely. That's what it's all about. And I think that, well, I've found so far that it comes back about 10x of what you've actually put in or gave out, should I say?
Absolutely.
Well, that's great. Well, yeah, this is a good point for us to end things. So, like I said, once I have those links from Ben, sure, then what we'll do is we will put those in the video description. But thank you very much, Ben. And
thanks for having me.
Yeah, once again, you can, if you want to catch up with Ben, you could also join our Discord. You can join the Discord on theaudioprogrammer.com/community. And it's a place for all of us to help learn from each other and to pass on what we know to other people and become better audio programmers. So for now, I guess we'll sign off and I will end the live stream here. And thank you everybody for tuning in. Oh, wait, we got one more question here. Do either of us develop music hardware, or are we interested in entering that field? Ooh, hardware. That's a whole different one.
That's a whole other question.
Yeah.
I have seen like people take JUCE plugins and make like little standalone boxes out of them. There's something called Elk OS, if you want to Google that, which is like a little like Raspberry Pi box, and it comes with a specialized operating system that's designed to be like really fast for audio. And that's something that I like would be interested in once I have, the Imagen product up and running. I would totally be interested in creating that, but no, I don't know anything about it yet. It's just something I'd be interested in learning about later.
Yeah. Like you said, Elk have been doing a lot with that. They were on the channel last year, and if you search through through our video archive, you'll see that they did a presentation on that. Also, there is another company called Bella. They also do a hardware board as well. They also have some really awesome audio programming tutorials actually on here on YouTube. So BELA,
Nice.
Bella. Yeah, so they have some really good stuff, and that's also a great way to get audio onto some hardware. So that's great.
Awesome.
We will sign off now. So thank you very much to everybody who tuned in, and we will see you soon.